All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our natural language module. Let's have a look at what we went over tonight. Now, today we actually got to run some code, so let's pick up where we left off. So, if we could give these rules to a computer, explain to it what non-terminal symbols could be replaced by what other symbols, then the computer could take a sentence and begin to understand the structure of the sentence. So, let's take a look at an example of how we might do that. And to do that, we're going to use a Python package called NLKT, or the Natural Language Code Toolkit, which we'll see a couple of times today. It contains a lot of handful features and functions that we could use for trying to deal with and process natural language. Here we'll take a look at how we can use NLTK in order to parse a context-free grammar. We'll start off by importing NLTK. You can see that's our input here. Next, we will define a context-free grammar, saying that a sentence is a noun phrase followed by a verb phrase. Then we will define what a noun phrase, then defining what a verb phrase is, and then giving some examples of what we can do with these non-terminal symbols: D for determiner, N for noun, and V for verb. So this is our sentence, our noun phrase, being followed by the verb phrase, noun phrase, determiner, noun, noun, verb phrase, verb, verb, noun phrase. These are the words our determiners can be transferred out for. Determiners can be the, a. You get the gist of it. We went over it yesterday. Now, next we are going to use NLKT to NLTK to parse that grammar using this here. The parser equals NLTK, and then we're going to ask the user for some input. Change that in the form of a sentence and split it into words. And then we'll fuse this context-free grammar parser to try and parse that sentence and print out the resulting syntax tree. So let's get and run this and see what we get here. And it's not that big of a code, so we should be able to run it fairly easily without having to wait too long. So we are prompted to enter a sentence. Let's enter something simple. There's our syntax tree. As you can see, the sentence we typed in was, she saw the city. This is our syntax tree. We have our syntax, our noun phrase, now, she. It's our verb phrase, which is our verb, saw. Then our verb phrase, followed by a noun phrase, a determiner, the. Then a noun phrase, determiner by noun, city. She saw the city. Okay, so this was pretty simple. Let's take a look at code with a little more complexity. Here our sentence is still a noun phrase followed by a verb phrase, but we will add some other non-terminal symbols too. We have AP, adjective phrase, and PP for prepositional phrase. I'm pretty sure I spelled that wrong. Excuse me. And we specified that we could have an adjective phrase before a noun phrase or prepositional phrase after a noun, for example. So lots of additional ways that we might try to structure a sentence and interpret and parse one of those sentences or one of those resulting sentences. Now let's run this code and see what it can handle. So this is where we're going to type in our more complex code. As you can see, this is our new syntax tree with our more complex sentence. We still have our sentence here, our noun phrase, our noun. Let me move down some. You can see it's Aaliyah. Then we have our verb phrase with our verb kissed, another noun phrase with another noun, Brian, our prepositional phrase, our preposition before, our noun phrase, and our noun, bed. This is our more complex sentence here. Aaliyah kissed Brian before bed. So yeah, it is handling sentences quite well. Simple and more complex. So yeah, our program does run and it is handling our sentences quite well. That's all we did for tonight. I'm pretty sure it'll get a lot more interesting the further we move into this module. Like I said, it is the last module, so things should, I'm hoping, get a lot more exciting in this module. But of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.